I don't know anything else other than the right triangles, and I know two of the sides. So what thing do we use to figure out that third side? Pythagorean theorem. Okay, so on number 1, which one's the C?
The C is the X.
The C is the X. So the 4 and the 4 are the A and the B. So how would it look? What squared plus what squared is what squared?
4 squared plus 4 squared equals X squared or
Good.
C squared.
So 4 squared plus 4 squared equals X squared or equals C squared, whatever. Okay, so since X squared is by itself, I need to actually just calculate this side. Can somebody tell me what 4 squared plus 4 squared gives you? 32. Do I need to show anybody how I know that? Okay, and then how do I get rid of this little squared that's on the X? Oh, I square root it. So I square root both sides, and then that's going to leave me X is the square root of 32. And then sometimes I can leave it like that, sometimes I can't. So this is when I double check my list of perfect squares. And is there one that goes in there? 4 does and 16 does, but we want to pick the biggest one. So 16 is the largest perfect square that goes in there, and how many times? Twice. Okay, and then 16, he's the perfect square, so he's the one that I can clean up. What is the square root of 16? 4, and then you can't take the square root of 2, so you recopy, and that is the length of X. Okay, number 2, same thing, just another Pythagorean theorem problem. So what would it look like? What squared plus what squared is what squared?
3 squared plus 3 squared is X squared.
Good. 3 squared plus 3 squared is X squared. And then since X squared is by itself, I just have to calculate this side. And what do we get if we calculate 3 squared plus 3 squared? 9 plus 9, which is 18. So I get 18 equals X squared. And then I'm not allowed to keep that little squared there, so I'm going to square root both sides. And then that just leaves X as the square root of 18. Take a second and simplify that, and I'll call on somebody and see what you get. Brooke, what perfect square did you get to go in there?
9.
9 goes in there, and how many times?
2.
Twice. And your final answer?
3 square root of 2.
Good. 3 square root of 2. Because the square root of 9, that's the one you can clean up, and the square root of 9 is simply a 3. And then you just recopy square root of 2. You notice anything? That this side here ended up just being whatever the side was with the square root of 2 behind it. Over here, X ended up being whatever the side was with a square root of 2 behind it. Now, this doesn't always happen. This only happens in certain triangles. So let's talk about actually what kind of triangles these are. It is a right triangle, but it's also, it's isosceles. Yes, it's isosceles because these two sides are the same. And I heard Jake say it, but I don't know if everybody else heard it. So this angle will be congruent to this angle, and if these two angles are going to be the same, and this one's 90, and these have to add to be the other 90, Jake told me that they're going to have to both be 45. So that's a 45, and that's a 45. Because you remember how all three angles have to add to be 180? So 45 and 45 makes 90, and 90 plus 90 makes 180. So same thing here. These two sides are the same length, so it's an isosceles right triangle, which means the angle across from this side equals the angle across from this side. So once again, this is another 45, 45, 90 triangle. So some 45, 45, 90 triangles come out nice and neat like this. If you know the side, the two sides will be the same, and the hypotenuse will be whatever the side is with the square root of 2 behind it. So if you know the side, both sides will be the same, and the hypotenuse will be whatever the side is with the square root of 2 behind it. But not all of them come out so nice. So I just want to look at these pictures real quick and see if you can see which ones kind of look like the two we just did. Can you spot any down here that maybe look like the ones we just did, kind of? Okay, number 1. So here's my two 45-degree angles. So I know the side across from this angle will equal the side across from this angle. So if this side's 9, what's this one? 9. And then what would the hypotenuse be? 9 square root of 2. And that's simply just following what we saw up above. It's just unfortunately not all the problems are so easy. Now, what do you think about 2? Does number 2 kind of look like those up above?
Yeah.
So on number 2, they actually gave you the hypotenuse this time and said the hypotenuse was 25 square root of 2. So do you know what the sides would be then?
25.
They'd be each 25. Because the hypotenuse is whatever the side is with the square root of 2 behind it. Okay, so some of the 45, 45, 90s are really easy like that, and some of them not so much. So this is when I'm going to start doing something different that sometimes is confusing to students, so this is kind of a big lesson. But I'm going to do it with these triangles, and then I'm going to turn around in a second, and we're going to do it with 30, 60, 90 triangles, and hopefully after you've seen it with both, you kind of get the hang of it. So if it's a real simple triangle like these guys, I would just jump to the answer, and I wouldn't even mess with what I'm about to do. But if it's not so easy, like number 3, it doesn't quite have the same layout because this wasn't just a whole number. And same thing here, this isn't just a whole number, so it's not quite as simple. So this is what we're going to do. Up here in this box, it tells you that across from the first 45-degree angle, you're going to mark an X. So across from one of the 45s, you're going to mark an X. And then this means across from the other 45, you're going to mark another X. So across from the other 45, I'm going to mark another X. And then across from the 90, I'm going to mark an X square root of 2. So across from the 90, I'm going to mark an X square root of 2. And I'm going to label all my pictures like this. So we're going to practice. So down here, across from the 45, I label with an X. If you already see something there, put an equals between it and the X. Across from the other 45, I mark with an X. And across from the 90, I mark with an X square root of 2. Now I'm going to work in a different color, so if you happen to have like a different color, one where you could mark the X square root of 2 in one color and then another color that you could actually work the problem, I might suggest that, but you don't have to. So with all my pictures, I'm going to mark the X square root of 2 in one color, and then in a different color, I'm going to actually work it out. Okay. With all of these problems, we always have to know what X is. If we know what X is, the problem's not so hard. If we don't know what X is, then we have to work a little harder. So in my picture that I labeled, do we know what X is? Yes. X is what? X is 2 square root of 2. So up here when it says X, what do we know X is? 2 square root of 2. Okay, so that's how long that side is. That was easy. And then over here, it tells me to take whatever X is and multiply it with the square root of 2. That's what this means. So it wants me to take X, and what did we say X was? 2 square root of 2. So I'm putting a 2 square root of 2 in place of where the X is, and I'm going to multiply it by square root of 2. And then this is kind of like what we learned a little bit about yesterday, multiplying radicals. What do you get if you take square root of 2 times square root of 2? Square root of 4, which is just 2. Remember, multiply by 2 of the same thing under the radical. Shoop, out he comes. And then that 2 that's already out there, I'm going to multiply it with the 2, and that makes this side have a length of 4. So this side has a length of 4, and these two sides are the same, which are 2 square root of 2. So it's a little bit different because it's not quite the same layout as the first two. Okay, 4. I'm going to do the same thing. I'm going to start off across from the 45. I'm going to label with an X, and it's really important if you have something there already, put an equals between it and the X. Across from the other 45, I'm going to label with an X. And across from the 90, I'm going to label with an X square root of 2. Okay, I always have to know what X is. So do I know what X is right now? X is 4 square root of 2. Okay, so since I know what X is, the problem's not that bad. So right here it wants to know what's X? 4 square root of 2. Okay, so that's how long that side is. No big deal. And this one wants me to take whatever X is and multiply by square root of 2. So what'd you guys tell me X was? 4 square root of 2. And then I'm going to multiply it with the square root of 2 there. And then square root of 2 times square root of 2 is 2. And 2 times 4 is 8. So there I did a little bit more in my head, but that's how long that side is. Okay, so 1 and 2, I just didn't do it that way because 1 and 2 were just a little bit easier, but I could have done 1 and 2 just like this. Okay, we're going to try some more. Now, number 5 would have been an easy one if this would have said 6 square root of 2. If this would have said 6 square root of 2, this side would be a 6 and this side would be a 6. But because the hypotenuse isn't something square root of 2, then I'm going to do something different. So I'm going to start with my labeling. Across from the 45, I label with an X. Across from the 45, I label with an X. And across from the 90, I label with an X square root of 2. But because there's something there, I have to put equals X square root of 2. Okay, every time I have to know what X is. These are the X's. Do I know what X is? I do not know what X is this time. And these last two problems, right here I knew X was this. And right here I knew X was this. And this problem, I do not know what this X is, and I do not know what this X is, but I am going to solve this equation, and I'm going to find X. So off to the side here, and I'm going to write it with the X on the left, just because it's a little more comfortable for me. I'm going to solve this equation. Okay, the goal is to get X by itself. These two things are smushed together, which means multiplication. How do you get rid of multiplication? You divide. So I'm going to divide both sides by the square root of 2. On the left-hand side, these two are going to cancel out because anything divided by itself is 1, and 1 times X is just X. So basically they just go away. Shoop! And I'm left with X equals 6 over the square root of 2. But yesterday we learned something. Do you remember what we learned? Yes. You cannot have a radical in the denominator. He can't be down there. And the reason I can't divide these and get 3 is because they're not both under a radical. So I need to get rid of him. So this is where the foo comes in. What is it?
Fancy form of 1.
The fancy form of 1 and square root of 2 over square root of 2. So it's whatever's in the denominator over itself. That's our fancy form of 1. Okay, so now we're going to multiply straight across, straight across. What is 6 times the square root of 2? 6 square root of 2. And then in the denominator, what's square root of 2 times square root of 2? Square root of 4, which is 2. So if you could do that shortcut, see that you're multiplying by 2 of the same thing, shoop, out he comes, then you could skip that whole square root of 4 step. Now, the only other thing I'm allowed to do is I can reduce that right there because neither of those are under a radical. And what's 6 divided by 2? So I get 3 square root of 2, and that's what X is. Once you have solved for X, then you can put them back in your picture. So this is what X is. So when this says, hey, what's X? Would we just find X to be? 3 square root of 2. And here it wants X, and we said that it was 3 square root of 2. And so now I know all 3 sides. These 2 sides are 3 square root of 2, and this side is a 6. It was given to me originally. So with all of these problems, you always have to know X. This one was harder because I didn't know X to begin with. Jonathan, get off the phone. Cheyenne, get off the phone. Okay. Well, this isn't typically easy for students. That's why I'm griping. Most students tend to struggle with this, and I know because I've been teaching for a long time. Last year when I taught this, and it always seems the same, when I teach a lesson, most students are like, oh, I get that, I get that, I get that. And then the next day, I have no clue what we did yesterday. I thought I understood. I have no idea. And last year, it was the same story, and then we revisited this again like later in the year when we were doing volume and surface area, and it finally clicked for some people then. But I hated for them to have waited so long for it to finally have clicked. I'd rather have it click now and you're like, oh, I got this, and then later when we do it again, you're like, oh, this is easy, no big deal. So this is typically harder for students, so that's one reason why I want you to focus. And this one, like number 5, if this would have said 8 square root of 2, these 2 sides would be 8 and I'd be done. But it's not. So here I go with my labeling. Across from this 45, I label with an X. Across from this 45, I label with an X. And across from the 90, I label with X square root of 2. But because something is there, put equals between it. And a lot of times students will not put that equals, and it will throw them off. So make sure that if there's a number there, you put an equals between it and whatever you labeled with. Okay, do I know what Mr. X is? Yep. I do not. But I can solve this equation, and I can figure them out. So off to the side here, I'm going to write it down, and I'm going to solve it. So tell me what to do. It's just like the last one. Divide by square root of 2, because that's how you get rid of multiplication. Anything divided by itself is 1, so shoop, that's gone. And all you're left with is 8 over square root of 2. But like the last problem, I cannot have a radical in the denominator, so it's foo time. What is he? What's your fancy form of 1? Square root of 2 over square root of 2. It's whatever's in the denominator over itself. Okay, now I just multiply straight across, straight across. What is 8 times the square root of 2?
8 Square root of 2.
8 square root of 2. And denominators, square root of 2 times square root of 2? 2. Out he comes. And I can reduce, and 8 over 2 would reduce to be 4 square root of 2. Well, that is what x is, and once you know what x is, you're allowed to plug him in. So x is 4 square root of 2, so right here when it says what's x, I can put 4 square root of 2. And right here it says what's x, I can put 4 square root of 2. And now I know all three sides. These two sides are both 4 square root of 2, and this side's an 8. Okay, let's try the next one. So on this one, because it's not just a 5, I can't just go 5 square root of 2. So I'm going to do the label. Across from the 45 is x, so because something there is there, put an equals between it and the x. Across from the other 45, label with x, and across from the 90, put x square root of 2. In my opinion, this problem is easier than the last two because you know x right now. In the last two problems, you didn't know x to begin with, and you had to solve for them. But right now, you know what x is. What is x? X is 5 square root of 6. So as long as you know what he is, we can start working. So this wants x, and what is it? 5 square root of 6. And this one wants you to take x and multiply with the square root of 2. So what did you say x was again? 5 square root of 6, and I'm going to multiply it with the square root of 2, which would give me, I'm going to write it over here so I have a little space. These guys, what would those multiply to give you? 5 square root of 12, okay? So 5 square root of 12, and then sometimes I'm done, it's just that pesky little 12 can be broken down. What perfect square goes into him? 4. So 4 goes into 12 how many times? 3. And then I can break down the square root of 4 into a 2, so I get 2 square root of 3. And then this 5 that's already out, he's going to drop and multiply and give me 10 square root of 3. And so that is how long this side is right here. So these two sides are both 5 square root of 6, and this side's 10 square root of 3. How are you feeling? We're going to do it again in a little bit with the 30, 60, 90. It's just they're different labels. Process is the same, but they're going to be different labels. Before we do that, I wanted to do a real easy word problem, though. So it says that we've got a high school softball diamond, that it's a square, and it says the distance from base to base is 60 feet. So the distance from home to first would be 60. The distance from first to second, 60. That's 60. That's 60. And then it says to the nearest foot, how far does a catcher throw a ball from home plate to second base? So here's home plate, here's second base, and we want to know that distance right there. Do you notice anything about this triangle? So it's a right isosceles triangle. Since these two sides are the same, I know these two angles would be the same. I know that this is a 90-degree angle here because it says it's a square. And so that means that this is 45 degrees, this is 45 degrees. Does this look like one of the easy ones we talked about at the very beginning, or one that I should bother labeling? It's an easy one. If this side is 60 and this side is 60, what's the hypotenuse? 60 square root of 2. And I could have solved it with the whole labeling mess. It's just, if you know the sides are just a whole number, then it's easy. Or if you know the hypotenuse is a whole number with the square root of 2 behind it, you can fill in the sides. Okay, so that's how far it is. The only thing is, it says to the nearest foot. So I am just going to put that in my calculator just the way I wrote it on my paper. 60 square root of 2. And hopefully everybody knows where the square root is, so that wouldn't be an issue for you either. And you get, what would you say to the nearest foot?
85.
85. Okay, so this is approximately 85 feet. Alexis, it's so nice of you to stroll in. We're having a fun day. Well, maybe not. But maybe. Okay, you ready to do it with 30, 60, 90s? Okay, here we go. So 30, 60, 90s, none of these are really super easy. Some of the problems are easier than others. It just depends on the layout. But we have different labels. So this goes like this. Across from the 30, you put an X. So I'm going to practice up here. Across from the 30, I put an X. This means across from the 60, I'm going to put an X square root of 3. So across from the 60, I'm going to put an X square root of 3. And then this means across from the 90, you're going to put a 2x. So across from the 90, I'm going to put a 2x. So I'm going to do these problems just like I did the last ones. It's just they're different labels. And like the last problems, if you know x right off the bat, they're going to be easier than when you don't know x. And if you don't know x, you just solve an equation for them. Okay, so here we go. Across from the 30 is an x. Across from the 60 is x square root of 3. And across from the 90 is 2x. See how there's something there, though? So I need to put equals 2x. And eventually, you'll know these. I mean, you'll memorize them eventually. You'll just know it because you'll have seen them so many times. Okay, this is x. Do I know what he is? Well, yeah, but at the moment, if I just look right there, do I know what x is? No. So I have to solve an equation for him. And this is the equation I'm going to solve right there. So if I were to solve the equation 2x equals 8, what would I get for x? No, you told me a second ago. 4. I would divide both sides by 2, and I would get 4. Once you know what x is, it's easy. You just plug them in wherever the x is. So when this says, what's x, what did we just say x was? 4. So that's how long that side is. And when this one says x square root of 3, what's x? 4. So it's just 4 square root of 3. So this one was easy, even though we had to solve for x. You'll see some of them are harder than others. Okay, let's look at number 2. Number 2, across from the 30, I label with an x. Because it's not a number, I'm not going to put equals x. Across from the 60 is x square root of 3, but because there is a number there, I'm going to separate the 5 and the x square root of 3 with an equals. And then across from the 90 is a 2x. Okay, if I look just where my x is, do I know what he is? No. So I have to solve this equation right here. And that's one reason why it's really important to put the equals between, so you know that's your equation to solve. If you don't put that equals there, sometimes students don't realize that's the equation they're supposed to be solving. Okay, so I'm going to solve them off to the side. I'm just going to put the x square root of 3 on the right and the 5 on the left. Just switching it around. Can you tell me what to do? Because it's like earlier problems we saw. Divide by square root of 3. You're trying to get Mr. X by himself, and that's how you get rid of multiplication, is by dividing. Anything divided by itself is 1. Shoop, that's gone. And you're left with x equals 5 over square root of 3. Foo time! You can't leave a radical in the denominator. So what's your foo? What's your fancy form of 1? Root 3 over root 3. It's whatever's in the denominator over itself. And then you multiply straight across. And what would that be? 5 square root of 3 over 3. Now on the other page, I was able to actually simplify right here, but these guys, they don't simplify, so that's it. So that's what x is. So everywhere I see an x, I'm going to plug that in. So up here, this said, what's x? Well, what do we just find x to be? 5 square root of 3 over 3, so that's how long this top side is. This one wants you to take 2 times x. Now, I could write it down, but can anybody in their head tell me what you get if you take 2 times x? If you take 2 times this, does anybody know? If I took this times 2? 10 square root of 3 over 3. Now, I'm going to plug it in. It's 2 times 5 square root of 3 over 3. What's this 2 understood to be over? 1. And so when you multiply fractions, you multiply numerators and denominators. So numerators would give me 10 square root of 3, and denominators would give me 3. And that is how long that side is right there. So that says 10 square root of 3 over 3 if you can't see it. But if you can multiply that in your head, you don't have to show me your work. I don't care. A lot of times students will tell me it's 10 square root of 3 over 6, though. They'll multiply the numerator and the denominator by 2, so don't do that. Okay, number 3. Across from the 30, I label with an x. Because something's there, I'm going to put equals x. Across from the 60, I label with x square root of 3. And across from the 90, I label with 2x. Okay, every time I need to know what x is. If I know what x is, I'm ready to roll. If I don't know what x is, I have to solve an equation. The last 2 problems, I had to solve an equation. This equation was easy peasy. This equation wasn't as easy. But after you do several of them, they get real easy. In this one, do I know what x is? Yes. I do. I'm ready to roll. This is what x is, so I'm going to plug him in everywhere I see an x. So this one tells me to take 2 times x. So that means it would be 2 times the square root of 6, which is just 2 square root of 6. This one wants me to take x times the square root of 3. So what is x again? square root of 6, so I'm going to take square root of 6 times square root of 3, which is square root of 18. Can anybody simplify that in their head? 9 goes in there twice, so it would be 3 square root of 2. And I'll just write it up here. So I know that was skipping a little bit of a step there, but does anybody need me to write down that 9 goes in there twice? And then the square root of 9 made the 3? And then you can't take the square root of 2? Okay, let's try just a couple more. So number 4, across from the 30, can you tell me what to label? X. Because there's a number there, I'm going to put equals X. Okay, across from the 60? X square root of 3. I'm not putting an equals this time because it's not a number. And across from the 90? 2x. Okay, so every time I need to know what x is, do we know what x is right off the bat? We do. So this problem is pretty easy. I know that x is 12, so I'm just going to plug him in everywhere I see him. Can you tell me how long this piece would be? 12 square root of 3. Because x is 12, and I just recopy square root of 3. Done. And then this one wants you to take 2 times x, so it would be 24, because it wants you to take 2 times your x, and your x is 12, so that side would be 24. Some are easier than others. It depends on what they give you. Okay. Let's look at 5. All right. Again, help me out. What do you label across from the 30? X. Across from the 60? X squared of 3. And across from the 90? 2x. Now, because there's something there, I need to put equals 2x. Okay. So right now, do I know what x is? Nope, so I'm going to solve the equation, and this is the equation I need to solve right here. And what is it if you solve it? 5. So you get x is 5, and if x is 5, how long is this side?
9.
No, it's 5. And how long is this side?
20.
5 square root of 3. It's funny to you because you know what you're doing. But if there's other people in here that maybe don't know what they're doing, and you're like, it's 20, and they're like, it is? All right. How are you feeling about this? You can do it in your sleep? Okay. So, unfortunately, I am giving you an assignment tonight. I'm going to give you 5 minutes so you can try to get started on it. I know 5 minutes isn't a ton of time. But you've got 6 problems on the 45, 45, 90, and you've got 6 problems on the 30, 60, 90. So, I know. And then tomorrow we're finally going to do whiteboards. And I think we'll do whiteboards on Friday, too. Do I have people in here that are going to be gone Thursday, Friday, Monday, Tuesday?
Just Thursday.
Okay, so that's one reason why I decided to just teach it all today, because I have a lot of people gone on Thursday. So Thursday and Friday will just be whiteboards. And I don't know that I need to even give another assignment. Ray, did you raise your hand that you were going to be gone?
I'll be on Thursday and Friday.
Okay.
Or the other Friday.
Here's for you. I don't want that. I say you Are you going to say, yeah. Initially, my game plan initially was to teach the 45 today and the 30, 60, 90 tomorrow. But I have so many people gone tomorrow, I just decided I'm just doing all of it. Yeah, so tomorrow and Friday, we're just going to do whiteboards. We're going to practice these special right triangles. We're going to go back and practice Pythagorean theorem and just make sure you're good. Initially, we were supposed to have a quiz on Friday, but I think I'm going to push it to Monday. I know that I don't really like quizzes on Monday, but I think it'd be better for you if we push it to Monday.